Hello and welcome to my academy. So this is the second video on bisection method of numerical analysis. For in-depth explanation to numerical methods, do well to take a look at the description of this video. I've posted the link of the first video in the description so you can look up for proper understanding. So in this video we are going to be considering this question. It says find the root of the equation sin x equals 1 over s correct to 2 decimal place using bisection method. So first of all, we have to write our functional equation. You're given sin s to be equal to 1 all over s. So this simply implies that sin s minus 1 all over s is going to be equal to 0. Okay, so we simply call this f of s. This implies f of s equals sin s minus 1 all over s, which is equal to 0. Okay, now like I said in the first video, our main target now is to find 2 points a and b such that when we plug into this function, it will change directly from positive to negative. As usual, you always start with a very small value, so you simply say let s be equal to 0.5. Now you observe that you can't select s be 0 because you have 1 over x here, and if you say 1 over 0 you're going to be having infinity. So to avoid that, you simply start by guessing s to be equal to 0.5. So that means f of 0.5 becomes, in place of sin s we have sin 0.5 minus 1 all over 0.5. So when punching this, please don't forget to put your calculator in radian mode. Okay, to punch sin 0.5, do not forget to put your calculator in radian mode. Okay, so you simply put your calc in radian. Okay, so having done that, f of 0.5 is now going to be equal to, now let's find sin 0.5. Sin 0.5 simply gives us 0.4794. 0.4794 minus, let's find 1 all over 0.5. that simply gives us 2. So 0.4794 minus 2, this gives us negative 1.5206. Negative 1.5206. Now this value is less than 0 and it is negative. Okay, so we try next putting s to be equal to 1. Okay, let s be equal to 1. Since we've done 0.5, we consider s to be 1. So we find f of 1, that becomes sin 1, okay, minus 1 divides 1. So this is going to be equal to sin 1. Sin 1 is simply 0.8415. 0.8415 minus 1. Like I said, don't forget to put your calculator in radian mode. That's the only way you can have the accurate value of sin 1 in radian, right? Okay, so you have 0.8415, okay, minus 1. So once again, f of 1 simply becomes, okay, minus 1. That gives us negative 0.1585. Negative 0.1585. Again, this is less than 0 and it is negative. So we've obtained two values that are negative. Okay, this is negative. The previous substitution also gave us negative, and we are looking for a positive value. So we'll try another value. Okay, so we try another value. Since we've done f of 1, now let's try put s, or let s be equal to 1.5. So you find f of 1.5. This is going to be equal to sin 1.5, okay, minus 1 all over 1.5. So this is going to be, okay, let's just punch all together just to save time. F of 1.5 is going to be equal to, so I'll punch everything together just to save time. Sin 1.5 minus 1 divides 1.5. So this simply gives me 0.3308. I have 0.3308. Again, this value now is positive, so this is greater than 0 and positive. So I have now a change from negative to positive between 1 and 1.5. So this simply implies, remember I said in the first video, a is the interval of the value that lies on the negative side, and when we put in s as 1, we obtain the function to be negative, so a is equal to 1, and b is the value that gives the function a positive result, and when we put in the value of s as 1.5, we had it to be positive, so b is equal to 1.5. So therefore our interval which is a b is simply equal to a is 1 and b is 1.5. so this is our interval. Now, having found the interval, then we find the initial guess. The initial guess is labeled S0 and is taken simply as a plus b divided by 2. In this case, a is 1, so 1 plus 1.5 divided by 2. I'll punch everything together. So 2.5 divided by 2. That gives us 1.25. So this simply implies our S0 equals 1.25. Now let's begin the first iteration. So not forgetting the equation, function is equal to sine s minus 1 all over s. So now we find f of S0. Now you're plugging the value of S0 into this equation. It becomes sine, in place of s it becomes 1.25 minus 1 divides 1.25. okay, so this is going to be equal to, I'm punching everything together just to save time. Do well to punch along with me as well. So we have sine 1.25 minus 1 divides 1.25. So we have 0.1490, approximately 0.1490, and this value is greater than 0 and it is a positive value. It is positive. Since it is positive, and I said that a is the value of the interval that makes the function to be negative, whereas b is the value of the interval that makes the function to be positive. Now we have the function to be positive when we plug in S0 to be equal to 1.25 into the equation. So that simply implies that b is equal to 1.25. So b simply replaces what, or becomes S0. Now we are going to fall back to the previous interval, as can be seen here. In our previous interval, a is 1 and b is 1.5. Now we are going to change 1.5 to 1.25 in place of b. Then we'll have the new interval. So new interval becomes a still remains 1, whereas b is now changed to 1.25. So this simply means now that the root of the equation now lies between these 2 points. So we find the second root, which is called S1. You find your second root, which is S1. Now S1 is now going to be equal to also a plus b divided by 2. This is going to be equal to a is 1 plus b is 1.25 divided by 2. So this simply implies your first root S1 is going to be equal to, so let's find 1 plus 1.25, which is 2.25 divided by 2. That simply gives us 1.125. So S1 is 1.125. okay, now with this you can now carry out your second iteration. Not forgetting the function f of s equals sine s minus 1 all over s. So for the second iteration, you find f of s1, plugging in the value of s1 into the function, it becomes sine, in place of s1 is 1.125, as can be seen here, so it becomes sine 1.125 minus 1 divides 1.125. okay, so I am going to punch everything together. Do well to punch along as well to avoid calculation errors. So we have sine 1.125 sine answer minus 1 divides by answer. So this simply gives me negative 0.2227. So I have negative 0.2227. Now you see now that this result is negative. When we plugged in S0 into the function, we had a negative result. And I said earlier that A is the value when plugged into the function gives the function a negative result. So which means our S1 is now going to be equal to A. So we simply say A is going to be equal to 1.125. Then we'll fall back to the previous interval. In place of A here, which is 1, we are now going to be replacing 1 with 1.125, and BC remains as 1.25. Okay, so we're going to be forming our new interval. Alright, so A is now 1.125, therefore our new interval becomes 1.125, B remains 1.25. So this simply means that the root of the equation now lies between these 2 points. So we find the second root, S2. S2 is also going to be A plus B divided by 2. So this is equal to 1.125 plus 1.25 divided by 2. So this simply implies S2 is going to be equal to, so let's obtain that result, 1.125 plus 1.25 divided by 2. So that gives us 1.1875. We have 1.1875 for S2. Alright, so with this now we can carry out the third iteration. And remember I said in the previous video that you only begin to compare after the third iteration. So okay, so not forgetting the function f of x is equal to sine s minus 1 all over s. Okay, so now we find f of s2. So simply plug in s2 into the function, and s2 gave us here as 1.1875. So it becomes sine 1.1875 minus 1 all over 1.1875. So let's see what results we are going to obtain. So I'm pointing all together at once. Sine answer minus 1 divides answer. So we have 0.0853. Now this value is greater than 0 and it is positive. Okay, it is positive, greater than 0 and it is positive. And you recall that B is the value that gives the function a positive result. So which means we are now going to replace S2 with B or by B. So this simply implies that B is equal to S2, and S2 is 1.1875. We have 1.1875. That means our new interval becomes, so in the previous interval we had A to be 1.125 and B to be 1.25. Now we are changing B. Okay, we are now changing B, but we are keeping A as constant. B is now changed, so A remains 1.125. B is now going to be 1.1875. So it means that the root of the equation now lies between these 2 points. So this simply implies that our third root, S3, is going to be A plus B divided by 2, and that's equal to 1.125 plus 1.1875 divided by 2. So this implies S3 is equal to, so let's find the value of S3. So S3 simply gives us 1.1563. So you have 1.1563. I can put it here. So x3 equals 1.1563 approximately. So let's compare this root with the previous root, S2. S2 gave us here as 1.1875, 1.1875, and the question said we should find the root correct to 2 decimal place. Now you see, after the decimal place we have 15 for correct to 2 decimal place, but over here we have 18, so which means it hasn't converged. So we'll continue to iterate. Okay, so we'll carry on now the first iteration. fourth iteration. So not forgetting the value of the function f of s equals sine s minus 1 all over s. So we find f of s3, simply plugging the value of s3 into the function. That becomes sine 1.1563 minus 1 all over 1.1563. Okay, let's see what we are going to obtain. Sine answer minus 1 all over answer. So this gives us 0.0505. We have 0.0505, which is greater than 0 and positive. Now this value is positive. Since it is positive, as always, it means now that b is going to change to be what, x3, and s3 is 1.1563, so b becomes 1.1563. so the new interval now, okay, new interval is now going to be, since b is changing, a still remains 1.125, so we have 1.125, but b is now changing to 1.1523. Now this simply means that the root of the equation lies between these 2 points. As such, we can now be able to find the fourth root, s4, and this is going to be equal to 1.125 plus 1.1523 divided by 2. So we obtain the value of s4 to be equal to, so let's find this value, 1.125 plus 1.1523 divided by 2. So we have that to be 1.1387. So this simply implies s4 equals 1.1387. Now let's compare this with s3, which is the previous root, and s3 we had here 1.1563, 1.1563. Again we have 1.13, this is 1.15 after the decimal place, so which means the root has not converged, as according to the question it says we should find the root of the equation correct to 2 decimal place. So that simply means after 2 decimal place the value should be the same, but only one of these values has converged, which is 1 and 1, but then this is 3 and this is 5, so which means we have to still further iterate. So we carry on now the fifth iteration. Okay, and the fifth iteration is simply, remember, f of s is sine s minus 1 all over s. Now we'll find f of s4, which is the value of the function, as s equals 4. So we have sine, in place of s we plug in the value of s4, which is 1.1387 minus 1 all over 1.1387. so let's see what results this will give us. So sine answer minus 1 divides answer, so this gives us 0.0299, and it is positive, greater than 0, and it is positive. Since it is positive, it simply means that b is now going to be called s4, and s4 is 1.1387, so which means we form our new interval. Our new interval becomes, so from the previous interval we had 1.125 for a, so a still remains. Now we are changing b. Okay, so the new interval becomes a remains 1.125, but now b is simply 1.1387, and you have this. Okay, so which means the root of the equation now lies between these 2 points. As such, we can find our fifth root, S5, and that is equal to 1.125 plus 1.1387 divided by 2. So you simply have S5 to be equal to, so let's find this value, 1.125 plus 1.1387 divided by 2. That gives us 1.1319. So we have 1.1319 approximately. Now let's compare this root to the previous root. We have previously we have so we can compare these two, which is S4. Okay, S4 we had 1.1387, 1.1387, and S5 now we are having 1.13, again correct to 2 decimal place. So after 2 decimal place it has converged. We have there 1.13 and we have there 1.13. Okay, comparing this to the previous root, we have 1.13, 1.13, so which means the root of the equation has converged and it is simply 1.13. Okay, so that simply means that the root of the equation is 1.13, and that's where the solution ends. Alright guys, so that's it for that given question on bisection method of numerical analysis. In the next video, we are going to be looking at the root of the equation s minus cos s equal to 0 using the bisection method. I'm sure you want to be a part of that video, so do well to hit the subscribe button and turn on your notification bell so you don't miss out when that video drops. Please do well to like this video, share to your friends, comment nicely, and if you're new to the channel, do well to also subscribe. I will see you in the next video. Thanks.